So, when we're talking about the solutions to linear inequalities, it's actually pretty straightforward to be able to graph them. We get things called half planes, and the etymology there is pretty indicative because what we're getting is half of the plane. Remember, the rectangular coordinate system is built around two axes, two lines. So, if you have one line and half of it is true, half of it is false, the half of it that's true that you're looking for will be half of the plane. Maybe not the most obvious half, like not horizontal or vertical line in that way, but it will be half of the entire set of options. So, think about what we had for that x plus y is bigger than 2 case. We would end up with the half plane of things that are above the line x plus y equals 2 as what we were looking for, with the half plane below being the solutions to x plus y is less than 2, as we can see. Where, if we want to be able to graph a half plane, graph the solutions to a linear inequality, what we can do is start by replacing that inequality with an equal sign and graphing the linear equation, where we draw the line solid if we have a non-strict inequality, that is something to form at least or at most, and then draw a dashed line if it's strict, bigger than, less than. Then from there, we choose a test point from one of the half planes, that is, choose any point that's not on the line, where you substitute the coordinates of the test point into the inequality. Then, if you get a true statement, shade the half plane including that test point, and if you don't, shade the other half. So let's get one more quick example with how this process works, because it's actually pretty easy. There's a lot of steps here. It seems like it's going to be hard, but it's really not. So for our example here, we want to graph 2x minus 3y is greater than or equal to 8. So the first thing we have to do is actually graph 2x minus 3y is equal to 8, where you have the intercepts at 0, -2, and 3, 0 that you can build around. At this point, I'm hoping you know how to graph linear equations even when they're in that silly general form. If you can't do that by this point, I don't know how you made it this far, but you're probably not going to get much farther. Anyway, we have that graph there, and from that point, if we want to check this, where to be sure that's a solid line because we have a non-strict inequality, we can include the line in our solutions. It's kind of like that situation dealing with parentheses and brackets from earlier on with our original inequalities. We can just pick any point we want. And if we ever get to use the origin, we should use the origin because zeros are very easy to work with. And if you want to use the origin there, that means we would have 2 times 0 minus 3 times 0, which is equal to 0, which is less than 8. But we want things at least 8. So 0, 0, that is the origin, I don't know why I said that in such a clunky way, is not going to satisfy our inequality. And to get things that do, we take the side that is not including 0, 0, and get a graph like so. We get everything else. And that's how we handle things a bit more generic in this way, but often we can do this a little bit quicker if we know a bit more about the line, if we have maybe a better setup with certain types of things. We don't actually need to use test points, and that's what we're going to see next.